Okay, let's jump right into this explainer. We're going to crack open a massive cognitive secret hiding right inside the brains of 4-month-old babies. We're diving into some incredibly cool, groundbreaking research that literally rewrites everything we thought we knew about how, and more importantly, when humans learn to speak. So if you've ever thought babies were just sort of passive, cute little observers of the world, well, prepare to have your mind totally changed.
You look at a sleeping infant and you probably think they're just resting, right? Maybe dreaming about their next meal, but under the surface, their brains are actually working in absolute overdrive. We're looking at some fascinating research that asks a really fundamental question. Exactly when do their brains start wiring themselves for specific languages? Like, when do they stop being these universal citizens of sound and actually start becoming native speakers of, say, German or French?
To give you some context on why this is such a big deal, behavioral studies have told us for years that language-specific phonetic tuning happens somewhere around 6 to 12 months. That has always been the accepted window for native language locking. Before this, the general consensus was basically that from 1 to 4 months, babies were just broadly absorbing sounds, totally independently of whatever their native language was going to be.
But the researchers behind our source material, they asked an absolutely brilliant question. What if we just bypass behavior entirely and look straight at the brainwaves? I mean, a 4-month-old obviously doesn't have the motor skills or the attention span to show us what they know, right? So what if their brains are secretly wiring themselves for their native tongue months before they can physically show us? Let's investigate.
So, to solve this mystery, they set up this ingenious experiment. They compared 54-month-old German babies with 54-month-old French babies, and they didn't just pick these languages at random. In German, 2-syllable words naturally stress the first syllable. Think papa. But in French, it's the exact opposite. They naturally stress the second syllable, like papa. It is literally the perfect natural contrast for a test like this.
And this is where they set a brilliant acoustic trap. They used the pseudo word baba. By using a completely made-up word, they guaranteed that none of these infants had ever heard it before in their lives. It was a perfectly untainted test of rhythmic stress perception. They created a German-style version with a long ba followed by a short one, and a French-style version with a short ba followed by a long one.
Now, before we get to the results, you need to understand the tool they use to measure this. It's called the oddball paradigm. Think of it like sneaking a badly out-of-tune note into your favorite song just to see if your brain catches it. It's a classic neuroscience trick. You play a repeating pattern so the brain gets nice and comfortable, and then, bam, you throw a curveball. And because the babies don't need to actually pay active attention, it's perfect for testing tiny humans who might literally be dozing off.
Okay, so here is the setup. They played the standard ba-ba most of the time, about 83% of the trials. Then, they dropped in that curveball rhythm 17% of the time. And they just watched the EEG brainwaves to see if the babies noticed. To make sure the data was completely airtight, they actually did this in 2 separate runs, swapping which pattern was the standard and which one was the deviant.
What's really wild here is how tightly the scientists controlled these sound waves. We're talking absolute precision. They literally cross-spliced the first 100 milliseconds of the audio to be perfectly identical, meaning only the syllable length mattered. They didn't just record someone saying the words twice. They digitized the audio and physically swapped the beginnings of the recordings. Pitch, onset, the whole shebang was flawlessly matched, so there were 0 accidental acoustic clues.
So, if the baby's brain actually recognizes that oddball sound as foreign, or just harder to process, it produces what's called a mismatch response, or MMR. Now, in complex electrophysiological data, yeah, big word, I know, an MMR usually shows up in infants as a positive shift in brainwave amplitude. Basically, it means the infant's brain doesn't have an established memory structure for that specific pattern, so it has to work significantly harder, using extra perceptual effort to process it.
Right, so the setup is flawless, the babies are ready, and the EEG sensors are tracking literally every microsecond of neural activity. This brings us to the climax of our scientific detective story. The big question, are these 4-month-old brains already biologically biased toward the rhythm of their native tongue?
The visual proof here is incredible. The red data tracks our German babies, and the blue tracks our French babies. When looking at the brainwaves, the solid lines represent the normal, comfortable baseline, but those dotted lines? That is exactly how their little brains reacted when they were hit with the rare, deviant stress pattern. We are quite literally looking directly inside a functioning 4-month-old mind.
Check out how much harder the German babies' brains had to work when they heard the unfamiliar French rhythm. There is a massive, undeniable gap between their baseline and their reaction to the deviant sound. That right there is pure cognitive effort, a huge mismatch response. But here's the kicker. When the deviant sound featured the German-style stress on the first syllable, their brains just processed it effortlessly. Almost zero reaction.
And beautifully, the French infants showed the exact reverse pattern. It's like a perfect mirror. They had absolutely no trouble with their native rhythm, but when they were hit with the German-style stress, their brains lit up with a massive mismatch response. The symmetry in this data is honestly just incredible. It proves that both groups reacted strongly only to the stress pattern that broke the rules of their specific native language.
So what's the big takeaway from all this? Well, it tells us that by 4 months old, these babies aren't just passively letting sound wash over them. No. Their little brains have already built dedicated memory structures that are highly optimized specifically for the rhythm of their native tongue. Processing a non-native rhythm actually takes them extra perceptual effort. They are already specialized listeners, totally attuned to the unique linguistic environment around them. As the authors point out, this completely rewrites the timeline of human cognitive development. It pushes language-specific neural representation way earlier than any of the old behavioral studies ever suggested. And it's not that those older studies were wrong. They just didn't have the tools to look beneath the surface. Long before a baby can even babble their very first real word, their neural circuitry is already being profoundly shaped by the language they hear every single day.
So I want to leave you with this thought, just to marvel at the sheer raw processing power of the baby brain. If they are doing this level of complex neurological wiring at 4 months old, literally distinguishing millisecond differences in rhythmic stress and physically adapting their neural architecture to match it, what else are they soaking in while we just think they're taking a nap? It's a pretty wild reminder of how dynamic and honestly incredible human development truly is. Thanks for joining me on this explainer. Keep wondering and keep learning.